So hope you can see my screen. So last week we started, so welcome to week 2. So last week we started doing some introduction to Python. We downloaded Python IDE like VS Code or Casa, and then we started looking into basic principles of writing code, like how to write comments, do basic arithmetics and operations, and then data types like string, integers. We also defined a simple data structure, but first we defined like how to initialize a variable. So there's a variable. We also talked about simple data structures like list, tuples, dictionaries, set, and we define how to define them using square brackets, using the parentheses, using the curly brackets, using the key and value for the dictionaries and their characteristics. So those are, and also we introduce the control flow, where we said Python is an interpreter language, but there is a way we can control how it executes its scripts. So you can control them based on a condition. So you can have a condition. If a condition is true, you tell Python to do this. If a condition is false, you tell it to ignore some code, which is under this indentation. So we talked about also indentation. You said you can use the space button, you can click it 4 times, or the tab button, you click it once. So that is what we call indentation. So everything that you want Python here to be added, this control flow of if statement, you're going to put it inside this indentation, and then after head of this condition, so you're giving it, if this is true, do this, else do this. So if this is true, it's going to run this and then ignore this. If this is false, it's going to ignore this and then execute else. So that was the basic that we were discussing last week. And yeah, here is where we left. And I gave you some tasks. So we discussed using elif and if. So we said this is where we left to as the assignment. You can create using the control flow, a simple calculator that is going to take in a number, an operator, and another number, and it does basic arithmetic. So anyone maybe who can share the screen, who tried to attempt the problem. Anyone, please share your screen, maybe if you have a solution, and then you can go through it. Abigail? Hey guys, nobody's did the assignment. Anyone? Yeah, yes, William. Oh, sorry, I think I was muted. I couldn't hear. Okay, let me unmute just a minute. Okay, if somebody was talking, I couldn't hear you. I just remember I was on mute. So, yes, hi, William.
Hi, let me share.
Okay, let me stop sharing.
Okay. Hapo si bana? Ada ndogo nagara no astino presentation nagaras. Yeah, itu kira. Eh. Yeah, so you can see my screen?
Yeah, we can see it.
Okay, so I explain or I'm just showing you.
Yeah, you can just walk us through on a high level what is happening.
Okay, thank you so much. So I was working on a Python code. I was just preparing a simple Python calculator. So mine was, I started with a print to display the simple Python calculator. So at first, this one I was trying to look on something. You see, for a calculator, there is always the way you start. If you are not working for rate, you can you can stop it from what is it called? If you're not doing the calculation, you can switch it off.
Yeah.
So that is why I just put the while true or something. Then the input, and then I put the two whether to exit or to enter the first number. So if I press exit, exit it will stop from running.
Yeah.
Then takes a break.
Yeah.
Then I started with the first number that I put float. For me, I put float because I had there were only you taught us two, either float or
Integer. Yeah.
Integer. So for float, I think it is more.
Yeah.
I decided to use that.
Yes,
so then the second number, I use float input and then enter a second number. Then the operators, there is plus, minus, multiply, divide, exponential. Yes. Then the space, whereby whenever I'm asked to input a figure, I will choose from this. Then, so if the operator is an addition, I instruct it to print. Then from there, then is when I use elif. That if it is not that, it's a negative. I will use the negative. Then now for division, I had to input this in case it is a 0. It will not go. It will not divide. You say one. Oh, no, one like let's say 5 divided by a 0. So that's why I input like if it is a 0, if the figure is equals to 0, it will cannot divide by 2.
Yeah, and I just pause a minute there. So guys, you can see like the way he has done here, he is nesting. This is whatever he has done here. If you check on the elif operator is equals, and then inside that we have another if statement. So this is called nesting, where you can nest this codation. So inside a codation, you can have another codation. So you can check on the line 160 here, where he has given elif operator is equals. So this is checking whether the operator is divide. So inside this codation, you can also have another codation. So it's checking if it's a divide, and now it's checking. So it first check the first codation, which number is a division. Then it check the second codation, where if that number is equals to 0. So if it is equals to 0, so here we are checking two codation. So this is what we call nesting. It's a nice one here. Okay, yeah, thank you. Continue.
Yeah, so that is the print is inside because of it is still within the elif of the division.
Yeah, and just a minute. So and also, guy, notice if you look into line 160, what he has done here. So if you are adding another codation, you add another indentation. So if you check line 161, there is a two indentation. So there is a first indentation which is for the main block, and then there is another one for the second codation. So you can see here we are using, if you're putting another codation, so you add another indentation. So that's also something you should note down. And also, yeah, so this is a great. Continue.
Yeah, so then I put now else print num1 divided by num2. Then the operator was exponentials. Then it's called exponential something.
No, so yeah, this one is called modulus. So this one is the one that.
This is the modulus.
Exponential is
the multiplication.
Yeah,
yes. Okay.
When you multiply it twice, you have asterisk and an asterisk star and star. That is the exponential. And now this is modulus. Yeah, continue.
Okay. Yeah. So then there is this one, the last one. Now, if in case everything is invalid, if everything is not okay, then it can print invalid operator.
Ah, nice. And now also, guys, you can see now the final here command always it's else. So maybe you can run your. Would you quit this meet.google? Just quit. You can see here there is another. Yeah, this one that is popping up there, meet.google.com.
Oh, what's this one?
Yeah, okay. Cancel that one. So you can see. Okay. Nice. So run your program.
Okay. So yes, So okay, let me this one. Let me just.
I think those one are printing because you had.
So I know it is asking me that there is something I run. There is another code I'm running up there of the one for phone balance and something.
Okay.
I'm not being able to stop it, but okay. So let me put the 7. Now here is the simple Python calculator. You can see. Yeah. So enter the first number. Let's say if I put 5, then it will ask me for the second number, 6. Then now it will give me the. I choose the operator. So let's say let me choose addition. Yeah. Then I can go ahead. So it is giving me 11.
Oh, nice.
Yes.
I run it again, and then you put an operator, and then put divide, and then you put number 2 as 0. So you see if.
So now if I put here I can put another number.
Yeah, I wanted now we do division. And,
okay. Yeah. So how can maybe you can help me on how I can stop the other one that are up here? How can I stop them from running? Then I'll only remain with the other one.
So this one we just put. You remember the one that we introduced for commenting out using multiline, where you put 3 quotation. So you can put
how many quotation?
3 quotation. You can put 3 quotation on the beginning of your file, or yeah, you want to comment out which part?
The up there, like from calculator up.
Oh yeah, go to line 1, number 1.
140.
Yeah, no, scroll up to line 1, the first line of your. Yeah, you put your cursor there, then hit enter, and then go to line 1. Put your cursor in line 1, then enter 3 quotation marks there. Another one. Delete the extra one. It just added an extra one, so that you just remain with 3. Yeah. Now scroll down up to where you are having your calculator. Link 140. Yeah, you see there. Scroll up.
Yes,
go to line 140. Put 3 quotation mark. Control save. Save your file again now.
Okay.
Now first you can exit. Click on the terminal. Click on the terminal a bit. You see on the terminal, just click anywhere inside the terminal. No, where you have entered your first program. You see where your code is running, where you are typing those numbers 5, 1, 7. Yeah. Type exit first. No, don't delete that. Just type exit.
Anyway.
Yeah, inside there. Type exit. All is not typing.
Yes, so maybe let me
do
try.
Control C, yeah, or right. Control C.
Control C.
Yeah. Then right.
Oh, then I can right.
Yeah. Okay. Right clear. Yeah. Enter. Now run your program again.
Okay. The nice. First. So.
Now
so we can put another figure.
Yeah. Put another simple number.
Okay.
Enter. Put 0. Enter. And then put the operator as divide. That one slash. Yeah. Nice. So guys, you see this one is working as expected. Is a program. So now when you scroll down into your code where you have the division. Yeah. So guys, you see here the codation we are doing. We are taking the num1 in line 152, and then 153 is taking another number, and then operator we are checking we are taking the operation. For now we put division, so the first codation on line 155 is going to fail, so it's going to check the operator. And then here we have double equals. Somebody was asking the difference between using 1 equals and 2. So using 2 equals is checking the codation, and then using 1 equals is when you are using like a variable you want to assign. So this one here we are checking the codation, and this one is going to result to false because on our terminal we put division. So if this is false, it's going to assume line 156, and then also check the codation on line 157, then assume it because it's not minus until it gets to line 161, where it's going to get now. This codation is the one that is among all the codation he has put here. The codation on line 161 is the one that is going to result to true. So once it results to true, it's going to now execute what is the indentation. So here he is adding another indentation, and then he is checking another condition. So after the first condition has checked into true, he is going to the second condition, which is checking that num2 if it's equals to 0. So then it check this condition, and then it's true also. So because our num2 we have put as 0, that's why you see we have printed here cannot divide by 0. Yeah, so this is a good work, William. So thank you for that. Yeah.
Thank you.
Okay. So anyone else? Just quickly. Thank you, William. Now one lady. Yes, Rose.
I share my screen.
Yeah, you can share your screen. Mm-hmm.
Can you see my screen?
Yeah, I can see your screen. Mm-hmm.
Okay, so
Mm-hmm.
yeah, this is what I did.
Mm-hmm. Yeah, scroll. Yeah, nice one. Let's start where it started. And so guys, you see they are also using oil. So we are going to discuss about this oil and why they are using them. So yeah, we are going to have a discussion regarding that. But for now, let's just focus on if and elif. Yeah, so let's have a code walkthrough. It's just a minute. So this one is printing, print one add, two subtract. So it's like you are having a key here, and then option is equals a float. So you are converting. Remember guys, when you put sometime input from via terminal, you have to convert the input. When you're using the input, the data type is going to be a string, so you have to convert using float or int. So that's what we are doing here. And yeah, so you can also, just a minute, exiting if option is a 5. And so here you see, rather than is using these commands like 1 2 3 4 5 to present the operation that you want to do. If you want to do one, you can add. If you want to do two, you can subtract. Yeah, then you can walk us actually through those. What yeah, continue.
Yeah, so
Mm-hmm.
okay. Let me say I used this
Mm-hmm.
like while true because time sikuwa naitumia
Mm-hmm.
like it only allowed me to do one what
Mm-hmm.
operation and it's done.
Mm-hmm.
So I had to run it again and so that it can allow me like do the next one. But
Mm-hmm.
when you nest it
Mm-hmm.
under the while true,
Mm-hmm.
yeah, it allows you to do multiple operations.
Yeah, so yeah, so yeah, just a minute. So guy, what she's saying, yeah, you are correct, that. So this is a loop, is where you can imagine where you want your operation to be working as in a loop. So this is a loop, so it want to keep so when you don't have the while loop, and then you run your program, it's going to execute, and then after you're done with the calculation, it's going to exit your program. But now you don't want the calculator to exit, you want it to keep looping. So after you are done, you can continue with another calculation. So that's the essence of having a while. We call them loops, and we are going to be discussing about them this week. Yeah, so thank you. Continue, Rose. Yeah.
Yeah, so as I said up here, like I gave it a command, like I instructed it, command one
Yeah.
should add to subtract. So this is what I've said. I came and like typed here. So if option one, we add num1 and num2. If it's option two, we subtract. If it's option three, we multiply. And option 4, if the num2 is 0, like it should print error, like division by 0 is not allowed. then it can exit, like doing, like it can stop working. Yeah, and if also it's option 4 and we have the num1 and num2, we divide.
Yeah, and
Then else.
yeah, and just to cut you short, and also, guys, you can notice. So you see how there is a different way to kill an elephant here. So if you look into line 188, you can see here we discussed the data structure, and we said you can have a list. So here we are storing this kind of a variable inside the list, and then so we are storing all the operations that you can do there. Option 1, which is addition of option 2, so we are storing all this inside a list. So this is a combination of a list and elif. So you can see there is a different way to go about it. So there is no correct or a wrong code. So there's also a way to do it. Okay, continue, Rose.
Yeah, so after else, like I had to like type another print, but outside the else, because I wanted it to be like Python to understand it, like it is different line or something. Yeah, that's like a print result yenye nataka print.
Oh yeah.
Yeah, see, I can run now.
Yeah, I run the program.
Ooh.
You can clear. You can just say clear. Right there, clear. Enter. Nice.
Yes. So here now I choose my operation. Which one should I use?
Use any and do a multiplication.
So you can do multiplication and yes.
Wow. So yeah, so guys, yeah, so guys, you see, so this is what happened. If you see the last what has been printed here down is choose an operation. So the program now has not exited our calculator. So you can continue with another calculation. So Ebu put another number now. Let's do another number. Put another operation. You can do any of your choice.
Okay, we can do division. No, not 5, 4. And any number of your choice. Yes.
Yeah, so you notice, guys, that you're not exiting this program, so it keep looping back. So what is happening here, the while loop is a kind of also another control flow, that when you get to the bottom of the code and then everything has finished, you tell the Python to go back again to the certain point and then restart doing the operations again. And then once it get to the certain line of code, then it go back up again until maybe you type a codation like exit or all those. So this is a way also where you see the two of them, they are utilizing the while loop. Yeah. Thank you. Yeah, I think yeah, this is a good job, Rose. And,
yeah, you can also exit.
Yeah, nice. You see now when she type 5, now we are exiting outside the loop. So yeah, so also that one I think is perfect. Yeah. So yeah, asante sana Rose, hiyo iko poa kabisa.
You're welcome.
Yeah. So I hope, guys, you have seen how it's done. So if you're having an issue, you can just check into the recording the solution. So just something similar is what is supposed to do. Take a number. Let me reshare my screen. So you can see my screen. It's coming. So they are taking inputs, number, operator, and another number. Then they are printing output. So this is where we left, and that's how you are supposed to. Sorry, that's how you are supposed to do the assignment. Also, there were some of you who are asking regarding notes. So the other assignment was regarding GitHub. So I gave you a video which you are supposed to go and watch, and I don't know how many watch. So have you guys created your GitHub account? Maybe you can just react. If you already have it, you can just show a thumbs up. As I see Avino, I see Joy. So Daniel, you are not yet. Alma. So a couple of you, they already have it here. You already have it, Simon. Yeah, so I see a good number of you those who have it. A good number of you. They are having it. So to have the notes, you can just come here. So there is this where you're going to access them. So to have them, so GitHub is where you can come and do, is like an Instagram. Oh, Daniel, you're saying you have a solution also. Yeah, so Daniel, or if you have a, can you share maybe quickly? Are you in a position to share? Okay, no worries. So remind me tomorrow, you can share even your solution, you can go through it, we can have a walkthrough. Yeah. So GitHub, I said, is like Instagram, where you see like Instagram or maybe Facebook or other social media, where you go and post, you create an account, and then you post something. For example, Instagram, maybe you post a picture, and then somebody who are followed, they can follow along, they can give a comment, they can save, they can bookmark, they can do all those stuff. So this is the like social media for the developer, where you have you can collaborate maybe with your teammates. You can also do stuff like share the code rather than sharing it, and it has a very another. So there is two. I won't get into this, but there are two of them. There is what you call Git. So Git is a Git, Git is a. Let's see when I run this. So Git is the one that tracks a project. Let's say you see, for example, I'm doing a project. Let's say you are building an application, and then you want to do changes. So what it does is to take a snapshot of your project, the entire of it. You can save the state of your project. So let's say I want to add a new feature. So what's happening is when you're building a new feature, it can break and it can cause other issues. So you see, for example, application, if you check an application, they have versions. They have maybe version 1, version 2. So every time they release a new feature, they release with a new version. So if a new version is having, let's say it's having a security issue and you have just deployed and you have noticed that, so what they do is you roll back. You roll back to the previous stable version. So you can use Git to do this is called versioning and versioning control. So you can go and then you can roll back quickly. You can remove. So it is kind of a database, and actually it's a high level. You can call it a database that saves different state of your project. So once you are doing the changes, it tracks those new changes, and you commit them, and then you can push to production. And then if you want to do another changes, you can do. So it has those kind of versioning. So that one is done by Git. And then GitHub now is the remote version. So Git runs locally as you're doing your project, and then there is GitHub. So GitHub is where you push and you save them online. So here is online, and to check, you can connect the two of them. You can do, for example, Git remote -v to check. So this one I have not initialized a Git. So to initialize a Git, you do Git add, but I won't add into this one. So just a minute ago. So you're going to so to view the project, you can come here. For those who already have it, I'm going to go to my repo, and then you can so to view, for example, if I go to github.com, so you see everybody that I have followed, maybe like you can see whatever they posted. So there's a way like I'm seeing this, they have a new release. There's somebody in MCP. If I'm following anybody that I'm following here, this is a kind of another one. They have they have released something new. See, these are releases. All these, somebody else there, they have shared maybe a new repo and all this. So these are how you do you have it. So you can go there and I follow. And then when I'm doing the changes, I'm going to be doing it on this repo. So here is the repo that you're going to get them. So for now, I've just pushed them here. Uh, ignore first the other one. So here there is this folder. So this is a kind of a folder. You can come and click here, and then there is a presentation for week 1, for example Monday, and you can open this presentation. So even for next year or years to come now, once you follow, and then so to bookmark this, just a minute, I'm going to show you. So you are going to come here, and you are going, and you can click. Then here there is a download button if you want to download them so that you can view them offline. You just come here. So all of them from for week 1, I have uploaded them for Tuesday. Come here, there is a PDF format and PowerPoint format. You can click into this. Sometimes it takes time to load. That's loading. You see, you are going to get all of them here, and you can click. You see here there is a download. So when you click it, you're going to have all of them. So rather than saving them for WhatsApp and then they get lost, so every time here you can come. So to get you can follow, and then here is a bookmark. You see, even like Instagram, how you put you bookmark a post that you like, maybe to review it later. So this is how we bookmark. So this is a star. So once you bookmark, anything that is going to be done here, any changes, you're going to be notified when you go to GitHub. So even you see, for example, those were 2 years ago and everything. So even 2 years ago, if you want to revise and everything, so just come and click this one here. So I hope everyone is it's clear how to access the note. Is it clear? Guys? Okay.
I have a question. So I need to log in on my GitHub account, then I search you, or how?
Yeah, you can just come to the URL I have shared here, or directly to this one. You can also come directly to this one. Not to this one. You can come to the DNS, so you can just click this one here. But you have to create an account. It's the same as social media. I cannot comment maybe on your Facebook post if I have not created an account. So you create an account, and then you can comment, you can follow, you can bookmark. So it's the same. Go to github.com, create an account, and then so once you create an account, you are going to come to this URL, and you can bookmark, and also you can follow so that you can receive updates when everything changes, and I upload more notes and assignments. So I'm going to upload more, maybe like this one here. We had some kind of interview questions, the one that you can be asked, different resources. What is Python? What is dynamic type language? What is an interpreter language? What is step 8? This we have covered. What is a scope? What is a list and tuples? What is the key difference between the two? What is the common between data types? We have covered the data types. What is class in Python? What are modules? We are going to cover, I think, this class or tomorrow. Unit test, docstring, slicing. There's a lot of them. Equaling. So these are resources, the extra resources. So go and bookmark. So once you bookmark here and follow everything, now you're going to have them even in the future, even if you don't have your laptop with you and where you have saved. So that's it. So let's get to today's class. So today we are going to be covering something that is called a function. So a function, and actually now we are about to finish maybe with the basics of Python, and then we start data analysis. So we are finalizing with the basic concept of Python, and then later you're going now to be using these basics that you have learned to do some work. So this is now the raw Python that we are doing, and then after, so this is like a foundation. And then after that, you're going to use all of what you have been learning last week and this week, and then you combine that. You can see how they were combining the while loop, the list, the control flow, and then combining all those, they were coming with a program. So it's the same thing that we are going to be doing. We are going to be combining all these, what you have been learning. We combine them, we come up with something new, and then maybe create some code, which is going maybe to access the database, create the bar graph, histograms, and those time series graphs, and then you can do some analysis, you can do some statistical, you can create the mean, the average, the variance, all those kind of operation. You can do them using Python, but you need some basic understanding of how Python works under the hood. So we are going to introduce functions. So function is a block that only runs when it's called. You pass data known as parameter into a function, and a function can return a data. So the issue that we are trying to solve now with the function here, imagine you have a basic, let's say an application. So an application is going to have different functionality. So you have a function for, let's say, login, and then forgetting a password. So there is a process that you want to be doing. Maybe send them an email. You have their email in the database, and then maybe you want to send them a code in their email, and then they are going to, or they can click a link, and then you're going to prompt them a new page where they are going to recreate a password. But now that situation, you are going to use it only when the user has forgotten the password. So you have a scenario and all this feature, but you're going to only use them when the user need them. So you're not going to be loading this code into your memory, your computer memory, every time you're executing your code. So for example, when I was running here, if I have not commented out anything, so you see all this, when I am going to run this code here. So Python is going to execute this and initialize in the memory, to have location, to have unique number. So it's going to have them inside the memory. So if you have a very huge code base here, and then you have just one big file, and then you're executing everything, but what you just need is something that was like a calculator. Like you saw when William was running, we had a situation where he had all this, and then when he was running, everything was printing here. So we are printing and executing other program that we don't need. So that is the issue that we are trying to solve. We want to modularize our code and have a clean code base, that when you are having a function, we are going to call it only when there is necessary. Like that example I've given, let's say a user have forgotten their password. So that's when you want to execute some code. So you want to call some code that handles the password, forgot password, and then you're going to maybe send them the email and do all this processing, checking the database, authenticate them, and all those kind of stuff. But you see that is a condition for only some user. So the user who has a password, they come to your page. You want your program only to run and check the password in the database if it match what they have put, and then they proceed to the next stage. So to do that, we are going to introduce functions. Function is a block of code that only run when it's called. So you're going to run that code only when it's necessary. So let's get started. So to create a function, we use built-in. So Python, it has built-in words. So built-in words is this command that I'm using. For example, else is a built-in word. Int, float is a built-in. But this string, for example, here when you are putting this is not a built-in. So there is those word that user. So there is a user word, and there is built-in. Built-in is those words that are commands that Python, like the one that you're using here. So this one, we are the one who are declaring this, but when we are declaring it, now this becomes like this is a variable, but you have declared it. But there is others, for example, the if. So the if here is a command, is a Python command that it understands. Also print, this is a built-in word. An input is a built-in word, built-in word, and the elif. So also we are going to introduce another one to tell Python that you want a function. It has a built-in word that help Python to understand what you want to do. So to tell a Python that this is a function that I want to be doing this kind of task, we are going to start with writing def. So you write a def there, and then after writing a def, you can give it a name. So you can give it a name like my function, or this is a function. Sorry, this is autocomplete is bothering me. So you can give it my function. So what's happened with the function? So here we have defined it, and then here you can give a word of your choice. So this is any name that you can give. Even here I can say greetings. So I want, once you log into my system, I'm going to give you some greetings. So I want you, maybe if it's a new user, have signed up into my program, I'm going to check if they are new user, and then if it's going to be new user, I'm going to invoke this function so that you can set them maybe hello, welcome to my whatever and whatever, blah blah blah. So we have it does that. So you define it like that, and then the next thing that you do, you put parentheses like this, and then you put these colons here. So you see what I'm doing. So here I'm defining. So def here, it tell Python this is going to be a function. Then this is going to be a name that you yourself are going to declare it. So you're going to declare the name of that function. So this one is, you can give any name, but for def you cannot change. For example, I cannot change this to put capital D. So you see this one here is now giving an error. So it has to be strictly to be def. But this one I can put capital G. So that one is also going to work. Because now this is not a built-in word. But for now, let me put like that. So you put it like that. And then inside, we are also going to be using indentation. So here I'm going to say print. And then I can say hello, welcome. Listen. Yeah, I can just give it a short message. You see, now here we just have the most basic form of a function. So there's a function, we give it a name, and then you see here I have a print. It's similar like what you are doing, but now when I run this, nothing is going to be printed. So here we are not checking a condition. Remember when I was writing with the if statements here, if there is not a function, here we are checking two conditions. And there is a way you are going to include, you can include a condition inside a function. But for now, I want you to check. Here there is no condition we are checking. So we just have a greeting and then your print. But now when I run here, you see, nothing is going to run. Reason being, function is a block of code that only run when it's called. So the next step is calling this function. So inside your code here, you can have now the elif condition here. For example, to check if a user exists in your database. So if it doesn't exist, you know that user is new. So if it is new, now you tell Python, you can execute. So Python is now not going, you can have all this logic, but now it has this function, but it's not going, it's not printing anything here. It's going to only execute now everything inside this function here only when you call this function. So Python is having all these script and commands that you have, but it's not going to kind of execute them. So it's going to execute them like print hello, thank you for using this program, only when you need it. So you can have some condition here, elif and if, to check, let's say you have connected the database, and then to call it, what you just do is you write greeting. So you write greeting like that, and then the parentheses. This is how we call calling a function. You are calling the function to execute the code inside it. So now you want to, once you call it, it's going to execute everything inside the indentation. You can see how much important is the indentation. So if you have a lot of condition here, maybe let's say it's a forgot password, you're going maybe to tell them, you can check the password. Some site they check the password. Let's say it check the length of the password. You can have a condition like that. It check the length of the password. Then you can fetch from the database the username, and then you can tell the password cannot be the same as as your username. And then you can tell them you have to use a special character. You can check the password they have inputted here, and then check all these conditions. You can check whether it has all these let's say the special character like exclamation mark, full stop, and all those slashes. So you can check those conditions. So now here, when I save this and now let me run, you see, now you are getting hello, thank you for using this program. I hope you find it useful. So this is what is called a function, and this is the most basic function that I have given here. So, but now, let's say you want to customize it. You want, for example, let's say we were creating the calculator we are creating there. So let's say we want to have, we are making a math program that is going to have a lot of functionality. So it's going now to do more complicated maths. So we may say it's going to be dealing with the matrices, calculating determinants, multiplying two matrices, and all those. And also maybe you have doing like algebras, calculus. You can have all those in code where they can put uh, their values there, and then you can, so you want to be having like all this elif here, and then you can check it, like if it's elif is a calculus, then you have all the codation here to run it, and then if it's an algebra, or it's this kind of arithmetics. So it's not professional to have all the logic printed here. So you want to have to modularize your work. You want to separate different functionality. Let's say you have a file that does all the kind of algebras, and then you have another one that do some different kind of math. You want to differentiate them. So to do that, we are going to, let's say for example, we want to have a function that calculate, we can say for example calculate, let's see example, one of example. Yeah, this one is a raising of yeah, this is raising a number to a power. This is calculating the cylinder. Yeah, so let me for example do this calculation there. So let's say you want to have your program also, you want to be calculating the volume. So in this scenario, it's not good to be checking elif they have given this, elif they have given this. You want to create just a minute. So you want to have, I want to come out clear, you want to have the formula. So you have the formulas to calculate this. So for example, for the volume, let's say you want to have a volume, this one. So there is the formula of it is pi r squared. So here we have pi and then radius squared times height. So what we want to try to do is convert this formula into code. So we want to create a program that does this. So to have this, you won't be having elif statement like elif they have given this, elif elif elif. You want to have like a code block that is going to have this logic. So to do that, we can now create a function. So in every situation which they are going to be using this function, you are going to be needing two things from them. They're going to be telling you, so here there is a constant like pi, so you won't going to be asking them pi, because yourself you know the pi. So this one you are going to declare it inside your program, but now they are going to be telling you the radius and the height. So if this is what they are going to give, these are input they are going to give to you, these are called arguments. So these are called R and H. They are inputs slash parameters. Some people you are going to be calling them parameters, or in some situation arguments. So I hope you are following through. We have this which we are going to give. So for this formula, for us to be able to calculate the volume, we are going to be needing two things from them. And those things that you are going to be needing from them are the ones that I'm calling parameters or arguments. So your input or your function, you have to be, and this is what I was talking when you are writing a function. You have to know the inputs they are going to be giving you, and the inputs your system is going to be expecting. And this is how you can extend them, where the people they do error handling, maybe you handle this scenario and etc etc. But for now, let's just check into this. So our function, we want it to be taking parameters or arguments. And now for this simple function that you are creating, we can see from this formula that you're going to be taking two arguments, the radius and the height. So to do that, now after you have this understanding, we can just create it. So I'm going to do def, like the way that you have said there, and then I can give the name that I want. So the name I can give, I can say cylinder and then you don't put a space. You cannot put a space like that, so it's good to join these two words, and then you put a and a underscore, and then I can give cylinder. So this is just autocomplete, I don't want it, but let's just keep coming. So you put the function here, and then I put the name of the function which you are going to call. So if you can just envision it as a user interface where there is a button. So once they click maybe this button, we want to load this function, and then this function is going to have parentheses. So you have the parentheses like that, and then you have the colons here. So this is how we define it. But now here, inside this parentheses is where we define everything that our function is going to expect from the user. So the parameters, we define them inside. So you see the first one here, I was not expecting. So if your function doesn't expect anything, for example, this one, you are not doing any processing. So there's a function that just take, it doesn't take an output, input, but it gives an output. But now this is a function that takes in an input and then do the processing, which is, this is the processing. And then after doing the processing, it gives an output. Like the portion mill. When you go to the portion mill, you put in this side the maize. So the maize are the input, and then you get the flour is the output. So it's the same scenario we are having here. So here we are going to define whatever this function is going to expect. So the first thing here we can have is we can say we are going to expect the height. So we can say we are going to expect the height, then comma, then the radius. So you see how we have done? We have seen a function, a name, and then the parameters that we need here. So the parameters and the argument. So we are going to expect it from them. Every time you call this function, they give us the height and the radius. So after that, you put the indentation. Then these are this here, you see this one here, we already know what is a pi. So we won't be asking them a pi. So you can ask them in the argument, but that is not going to be, is going to be a lot of, we want to offload them, all this kind of typing and all those. So because we already know what is it, when I come here, I'm going to create a variable, which is pi, and then equals, I'm going to assign, you see now we are combining the variable, and then I can say 3.14 for now. So here we are following along this formula that we wrote here. So we have defined the pi. After we have defined the pi here, now we can do the calculation here. So we can now define the volume. We are going to have another function, and then I'm going to say is equals, and then whatever we defined here. So it's going to be pi, and then we talked about the multiplication. This is the star. We're going to multiply, and then we're going to, you can put the radius, or I think it's not a must we put it into, I just put, yeah, let me just, to avoid confusion, let me do board mass. So I just put the radius, and then remember we said about exponential, when you want to raise a number to a power, you put 2 asterisk here. So I'm going to say 2 exponential to raise this radius to 2, and then I close the parentheses, and then I multiply by height. So you see here, the way we have defined here is the presentation that we have here. So this function is going to be taking it, and then take by radius and height, and then after that we tell the function. So this one was not returning. If you have here the inputs, you have to add another final argument here that is called return. So this is, it's going to return after processing. So here it is, inside the function here is where we are doing the processing. Then after doing the processing our inputs, we have to give an output. So we say return, and then we return whatever we have processed here. Our case is volume. So here I'm going to give, this is a volume. Do you have a question up to that point? Do you have any question? If you are understanding, you can just react with a thumbs up. Okay. So you can see now, I'm going to comment out this one because I don't want it. So now let me run my program. Nothing has been printed here. And the reason being, we have not called it. So the user on our user interface, maybe they have not clicked that button for to say. So let's say if they click maybe that function where they say they want to calculate the volume, we are going to now on the user interface you can give them an input box where they can type. You can tell them enter the height, and then after they enter you can tell them enter the radius. So to do that, on the background you have to be expecting to call this. So I'm going to call the cylinder volume, and then I'm going to pass the arguments here. So I call it, and then so these are going, whatever I'm going to put inside here is what the user is going to enter. So you can have, for example, the input. You remember the input that we are using to take user input here. I can have, for example, here. Let me define what we have just done there. So I'm going to define height. So I'm going to define height, like you remember what William had done there, where he was using float. So you can use a float or an integer. So remember we want to ask from the user. So this is going to be taking arguments from the user. So you see our program now is interacting with outsiders. So this is what is going to help us when they enter anything. Maybe they type from the front end or from the website. So basically, and then this is going to take whatever the input they have put. When they click enter, it's going to take it, and then so it's going to use the input. And remember the input, it give a string. So I'm using the float here to convert the string they have entered into a float. Now, remember to do the calculation, mostly you need these two data types. We discussed about the data types. We discussed about integer. So you want for now their input to be an integer. So when they enter anything, it's going to be a string. It's going to be like 25 in quotation. So we want to convert this quotation from a 25 quotation to a float. That is going to be, so if it's a float, it's going to be 25.0. So 24.0 we can work with it. But if you use int, it's going to be converted to 25. So I hope you are following through. So we have started here, we have defined a function, and then here we want to take inputs from the users. So once we take the input from the user, I want now to invoke our function. And now when I invoke our function, so when I save this one here and I clear and I run it here, let me say like two, you see we are getting error. So it's execute. Remember the reason that we get. So if it's other programming language, we have first to compile and then run. So you're going to get this error area. But for now, Python, you see, because up to this point we don't have any error. That's why you see it has run this part of the system. Then part of the program without any error. Python is an interpreter language, so it was executing the command line by line. But now when it gets here, you see in line 167. So this is where the Python was confused. And read the type error. So the type error here is saying the cylinder volume missing two required positional arguments. So it's telling this you here, when you defining this code, you define that this code should always be taking in the parameters and the arguments here. So the Python is taking now the codation that you yourself defined. So it's telling you area in your code, you define some codations that this function should take these arguments, but now the user, they want to execute the code without following your instruction. So you see now it's enforcing the user, they must pass the instruction that we defined here. So to avoid that, I'm going now to tell this one that is going to take the user, the height that they have put here, the height. And another thing, let me first write that height and the radius. And another thing, this thing you cannot interchange them. So if here you define the radius first and then the height first, when you're taking the input from the user, or when you are calling this function, you cannot start with the radius and then height. So the way you defined here, those are the rules that you have set. Now Python is going to be enforcing those rules. And if anybody try to break those rules, Python is going to throw an error and refuse to follow those instructions. So Python is going to follow your instruction, you the programmer. So here I'm now going to save it again. Let me do clear, and then I'm going to run again. Now it's telling me enter the height of cylinder. I'm going to say 10. Enter the radius. I'm going to say 7. So here return volume. It was supposed to print, just a minute. Cylinder volume. So here I can also do a print, just a minute. And now I print. Let me put this inside the print. Just a minute. Let me put again 10, 7. Yeah. Now here I'm calling the function here. I just put the print here so that we are going to print. So actually I can remove this extra. So I'm now printing. I'm now printing the cylinder, the output that you are going to get here, the volume that you are going to get from here. Yeah, let me confirm with this. Yeah, we are taking, we have done it differently, and then we are printing. Yeah, so let's go through the code again. We define a basic instruction here, a function. It takes an input and an output. So there's an output. Then we take argument from the user, and then we call the function here. So we call the function, and I think we can print here. Let me see if I can do printing. I'm not sure. No. Just a minute. I want to confirm something. If this is going to work. Just a minute. So this is not working. Cannot print there. So for now, just follow along this one. So it's a return a volume, and then now here we are calling it. So here at this line here is where we are calling the function here. So we are calling the function right at the, just a minute, I think I am supposed to, I'm trying to have it, to have the print inside here. Yeah, just a minute, let me see, save, yeah, it should work this way. Let me run it again. Nice. Yeah, this is what I wanted. I didn't want to call print here. Yeah. So now see, we are taking the volume. So after calculating the volume, here we are printing, and you are printing the output. So it's printing, and then it's just doing the return volume. So you can do either way. You can put print here, or you can put print here. So you have to have a print, so that, remember, the print is the one that give outputs, like print the result. So input, the input, it takes the inputs, and the print, it give back to the front end. Let's say like the front end in our case, which is terminal here. So you're just printing and return volume. So you can just return volume and then do the printing here of the volume. But for now, just doing it here. So but this is the logic. So this is the main logic that we our system is doing. So up to that point, do we have any question? Let me run it again. So now you see, enter the height of a cylinder. So Python has already executed this page, but it has not executed the logic inside here, because we have this is a function, and this is inside the indentation. So first it want to this is the one that now we are executing, and is asking for the height. So the height I'm going to give 10, and then it's going to ask for 166. Enter the radius, and now here I can give something like 7. And then after that is going to go to line 169. So now here is where it's executing doing what we have said is calling a function. So here we are calling the function, and then for each function we are passing arguments, height and the radius. So now we are telling the Python, so now go and call that function that I had defined, and now that function you put these inputs. The inputs they have already given. They have given us the height and radius. So if you have everything, now you can run it. So when I enter, you see, is calculating. I hope it has been understood. Okay. Okay, great. So you can do a lot of them. So I want to do another example, but you can go and think, for example, a number that raising to a power. You can even ask ChatGPT. Try also to do other examples with the ChatGPT. Let's try to give it a simple Python functions. You see, even the Python is doing the same thing. So here is doing the arithmetic. You can have so if you have an application that is doing a calculation, and this is what you're going to be doing. You're going, for example, to have a function that calculates the statistic. It can calculate the average of the data set, and another one that does the cleaning the data set, and then another that does the visualization to draw the histogram. So when the user they request the histograms, you have a function that does that kind of work and all those. So here is a number that calculates the power. I take a number in exponential. It takes the square root. It raises a number to 0.5 to a half. It calculates the modulus. It calculates the minimum, maximum, average. It calculates the factorial. You see, all those are function. Even you can tell it now give advanced malfunction. See now it can create a function to calculate the derivatives. This is a lambda. Lambda is a very interesting way of creating a function, but for now I won't cover it. But if you want to learn more, you can go to W3. So this is a way of creating a simple function. You use a lambda, where you give x and then you give x raised to a power 2. I will go into that, is not needed at the moment. You can see integrals, calculating the integrals. You can have a function where your application is calculating the integrals. You can have matrices operation where maybe they want to multiply two of them. So try to go through this code and try to understand it. So try to write as much as you want. Linear regression, Newton-Raphson, Fibonacci, vector dot, gradients, sigmoid. You see, all these are things that you can do. So try to go and run, but the basics remain what we have done here. See, nothing is changing. You're starting with a def and then the name, so this can change, and then the variables, and then the return. You see all of them, the def, the name, argument, colons, indentation, and then you see for this one is combining the if. Remember we learned about the if, so you can also have the condition if inside the function. So this is how it goes every time. You have the def, also here have the integral, have the arguments, and you see the, for example, this one. So in some, when you see an equals here, you can put the default value. So this is telling Python if they don't put a value, let's say if they don't put a radius, you can handle. So this is handling the edge cases. When they don't put an argument, you can have a default value. So when you see like n is equals 1,000, if they miss to put an n, your program is also going to run. But now you are going to replace n with 1,000. You can have default values. So you can ask Python like if you are learning why or uh, do n is equals 1,000. You see, it's giving two of them to instead of integral. Given, I wanted just a simple explanation. The one that you see, these are when you don't give an answer. So this is a kind of a handling You don't hard code and blindly or adapt dynamically or use a smart melody. Yeah, but basically that's you can define even the h here. You can define the height by default, and also for the case that we had here for the pi. If you want to take the pi from them, you cannot. You can also write the pi here, but because already you know pi is 3.14. Maybe for them they want a very accurate program. Remember, pi can be other numbers here, and this is a round off that you have done here. Maybe for their case they want to be very specific. As you add more decimal place, is the more your program is going to be more accurate. If they want, maybe they are doing atomic calculation where every millimeter matters. You can give them freedom of defining how many decimal places they want. So you can give, but you can give pi is equal to 3.14. If they miss to give, you default to using this one as the default. So that's kind of the logic we are using. So that's it. So, and to finalize, I wanted to cover the functions. There is another kind of a higher level that is called classes. But I don't think from somebody have a question. Okay.
Yeah, I wanted to request if you can copy paste for us the function on the message part. I think it will help us to learn as we go, even to study more on the, because I know we are trying to understand it. You can copy for us on the message part, and then we can take it from there.
Sorry, you want me to copy this one?
Yes, only that one. Yes, from the cylinder volume.
This one.
Cylinder, no, from the top. Yes, from volume of the cylinder. Yes.
From here.
Yes.
So somebody can share via WhatsApp, maybe for those who they.
No, you can share on the message.
Okay.
Yeah. Then.
But don't copy. Just try to look into it and then write the code. Because you see, when you're writing, I want you to get the errors like indentation error, so that you understand what it's doing. So try to just look into it. This one.
Okay.
Yeah,
yes.
But don't copy paste what I have done. So try to write the code by yourself.
Okay.
So I think classes, there is another way where you can have several functions. So I won't cover this into detail, but I just want to make you aware. So we have another higher level of functions. Let's say you want to group your functions. Let's say now you have even a broader application, and then you want to modularize your work. You want all the math functions to be under one container. So we call classes. So classes are the blueprint of creating objects. It defines new types data, and it have, so you can define new data types and all those. So I won't go deep into this for now because I want us to cover something else. But I'll give you the notes also so that you can check into it. So there is other higher level that is called classes, but for now I want us to just cover the functions. So you can see this is a class, and then inside a class we have a function. So you can have various functions inside a class. So if you want to have, for example, to have let's say that a very broad application that how does, let's say you want to have functions for handling authentication. So that one you can have a class for authentication. So you are going to have a class for authentication. Then you want to have another class for database. So handling the database connection and all those, you'll be having function. So all those functions, you can put them inside a class. So this is what you call like encapsulation. So encapsulation, you can ask even Python, what is encapsulation? Encapsulation in Python. So yeah, that is a basic way of we are encapsulating the code of similar function. Is it found? You see what it has done here? There is this a bank account. There is for example, this function here. It has initialized the first one and the second one. So also you can see this one is you want, for example, you have a system for your bank account. You want to have all the function inside one big container. Let's say for depositing, getting the balances, That one you have a class. Then you have your banking system, other function for authenticating the users, other functions for maybe giving them promotion offers and loans, telling them about the loans you have, calculating them, their credit score and all those, you have them. So I won't be talking much into this, but I just wanted you to know, to be aware of them. So you can go as a task for today, go and learn about classes. And now be introducing you to the import here. I want to introduce you quickly. So once what I've done here, let me see if what much you have left. Yeah, is a Python modules. This is I want to introduce quickly Python modules. So in talking into code, let me go to there is a code base that I had opened that we're going to be using. It's called NumPy. I'm going to be using this library a lot in manipulating the data. Where is everything here in my document? No. Yeah. So now you see how this is how the work is organized. You also from classes, so different classes like the way you are talking, you are going to have them in different folders. So for example, if here I have this for function for calculating this, I can have them in a different files so that my work can be more organized. So here you are planning your work on your building a system. You don't want to have everything inside your one file. So we want to have a scenario. If you look into this code base quickly, you see how much file. Even sometimes yeah, just look at this. Even sometimes you are going to have and you can see this is an open source. How many people they are working on this repository? Over 1,000, around 2,000 developers. So, and you can see, for example, this one, there is a developer who has been working into this 2 days ago. This one is 8 hours ago, 8 hours ago, 2 months, 3 years. Nobody has touched that one for the past 3 years. For the 7 years, nobody has touched this one. For 2 months, 3 days, there is a developer. So you can see we have all these contributors that are contributing. And then you can see they're using different languages. Some 60% they have used Python, other C++, other C, other C, other Fortran, and the other languages. So how do they interact with each other? So that is kind of a scenario that we are handling, where you are having mixing of them. But I won't be going into different languages, but there is a way you can write some program here in C++, and then I can make them, I can use them inside the Python. They can interact with each other, and I won't go into much into details into that. But for us, I just want how two different Python files interact with each other. Let me open one of it here. I can open each one, polynomials. So guys, you can see this one. This is a Python file, for example, and this is another Python file, and this is another Python file. How do they interact with each other? So you can see, for example, you can have a Python file that deals with the polynomials, another one that maybe deals with matrices, another one that deals with maybe all those kind of scenario that you can have. So you want to arrange your work in this way. So for example, if I'm a developer, I'm only interested with polynomials. I'm going to come to this file and then look how it works, and then I can do some implementation, and that is. So I don't need to know like what's happening everything here. I can be interesting. So when you are also assigning some tasks, let's say you're collaborating, I can tell you, I want you to add this functionality. So you can see how we have created a very clean code base here. Not that one. Let me click this one. So what they are doing here, is what I'm going to talk about. You see, import. So you are importing another functionality to your main file. There is import and there is from. We are using the two of them, from. So this is how the two of them interact. Function inside another file, they can interact. So you can have a, maybe inside your main file you want to call another for calculating the area, calculating the host. So this is what I'm talking about when I say Python modules. So Python modules, they can be defined as Python program file which contain Python code including Python function, classes, and variables. So I think we are running out of time. So this, I think this is where we'll pick it by tomorrow. So tomorrow we're going to be discussing that, and then after that I think we are going now to start. So this is a Python we have been covering. I think by tomorrow we are going to be done with most of the Python, and then from Wednesday we can start data analysis now. So if you get all the fundamentals, Python fundamentals, now we are going to use those fundamentals now to do the analysis, the data analysis. But for now, that is what I'm planning to introduce. We are going to have another here that I'm going to call, for example, arithmetics.py, and then I want to have functions here, and then I want this file here to interact with this file. So once you get the logic, because now when you are going to be working the data analysis, and one of the reasons that I'm introducing this, you're not going to be writing code from scratch every time. So for example, this is an NumPy. There is a lot of developers, they have implemented this, for example, if you have created your formula there is this one that is called PyPy. So if you have created your own formula, you can upload your project here. Let's say it's a mother formula you have created, and the other developer, even ourselves, you can see how many they have, how many users, over 1 million developers, over 770 projects. So all these are the projects. Even yours, you can upload it here, and you can look for it. For example, I can look for this project you have seen there, NumPy, and you can see it's here. So you can have all these formulas. You can upload your even your project here. You can try to look into YouTube videos on how to upload, and then I can even install. Let's say you have created a new library that does this and all this in Python. It does this kind of data analysis. It calculates maybe this kind of a statistical analysis. You can create yours, and then I can use it. So to use it, you can also use the local one, and also you can import online. So to import online, you download it locally using pip. There is something that we call it pip install. So when I say pip install NumPy, is going to behind the scene, all these files are not going to come here. So if you use pip, is going to download all these files, but is going to be behind the scene. So you are going to hide it, but they are going to be there, and then I can import your functions here. So that is what you're going to be dealing with tomorrow. Tomorrow I want us to look into that, and then from there, after we learn that, we can now start importing other code, because now we are not going to be writing the code from scratch in all scenario. We are going to utilize what other developers they have been building. So you can see this, it has been built for years and years. They have been building for us to use it for analysis. So we are not going to be writing code for analyzing data set from scratch ourselves, like the way we have done here for calculating the volume. This was a simple one, but there are going to be other very complicated ones. So rather than writing this, I'm just going to say import cylinder volume. So I'm going to say import cylinder volume. First, when I install NumPy, I have to know the function they have, and then directory. So two things I'm going to know is the name of function I want to use. They have created, so you have to be aware of that function and the parameter it takes. So I'm just going to say, for example, I could not have written all this code. I could have just said cylinder volume and then height and radius and then run. So that is going to help us a lot. Do you have any question? Somebody have a question? Okay. So if you don't have a question, guys, I hope you can meet tomorrow. Have a nice one, and remember to revise what you have covered today, so you don't get lost in the coming classes. So good night, and see you tomorrow, guys. Bye.